thank you so much for coming on the show. It's great seeing you because this is how we see each other through Zoom nowadays. Why don't you tell us a little about yourself and your organization and what you're passionate about?
My name is Dan Ciruli, and I run product management at a company called D2IQ. We build a cloud-native computing platform that we sell to large enterprises and to governments. And I am passionate about the next phase of software development and deployment, and how we go from a world where we used to all, when I started, it was on PCs, right? I guess before that there was mini computers and supercomputers.
Don't forget mainframes; those are still around.
I was never on mainframes myself, but and we went, and the web was the next kind of major thing where you had a web server, you installed software on it, and the next phase, what we call in the industry cloud native computing, is this kind of has these tantalizing, really exciting benefits that everyone talks about, but is going to be quite a lift to get the world there. Mm-hmm. And I think the benefits when we get there are you see these things that a very small handful of companies have been able to achieve, both in terms of the scale that they can reach, but also just how easy it is to ship software and how good they get at that. And when we can get the rest of the world right along that path, then what we're going to see is just more innovation. We're going to see things that we can't even dream of today. Average developers will be able to do.
Right. Can you tell us a little bit about sort of like the progression? Because it started off with everything on big mainframes and mini computers with terminals, right? Mm-hmm. And then we went to, okay, the processing moved to the desktop. So the desktop did the processing and the network just connected the PCs together. And then we went to a sort of a client server architecture. Then we went to a web-based architecture. Then we went back to a client server architecture. Now we're going to the cloud. I mean, can you tell us a little bit about that progression and then why we did all this stuff? Because it seems like we just keep moving around, but what were the benefits?
What happens is, I think every time there's an innovation underneath, and you skipped a step, because when we first went to PCs, they weren't networked. You wanted to get a file of that machine, you walked it over. I probably got a floppy disk here somewhere.
That's why they called it that.
That's why they call it sneakernet. Yeah. Every time there is one of these innovations, right? When you go from every computer is sitting there by itself to every computer is connected, or when we went from, you mentioned terminals. When I started working on PCs, we were using DOS. Mm-hmm. And when all of a sudden there was a graphical user interface, you change the landscape of the use cases you can address, and things that weren't possible before. Like my company back then, we were drawing, we did electric utility software, which is about as boring as you can get. And we said, hey, there's a thing called Windows now that lets you draw stuff on the screen. What if we graphed this for everybody? What if people could look at a graph of their usage? And it just hadn't been really possible before. And then all of a sudden it was possible, and it made everybody, it made the analysts better. It made consumers understand their power. Now, I've got literally three apps on my phone that show me a graph of my usage, right? Like that kind of stuff wasn't possible. So what happens when then the internet is connected, and you can put a server on the internet, and it's a whole raft of use cases that no one even saw coming. And even as the internet started to happen, if you remember, the first thing was, it was basically companies would get a domain name, and they would put up a site that said welcome, and that was it. Maybe some information.
It was basically an electronic business card. There was no functionality.
Absolutely.
In fact, it didn't even look that good because it had the gray background. And
well, it was under construction.
I always like going to the Internet Archive and looking at Amazon's first webpage, because it is hilarious. It's like Web 1.0, Netscape, gray background, lines, no tables, just a couple of images here and there. And I'm like, wow, look at how far they've come in 20 years, right? It's amazing.
Yeah. And so when these new capabilities, even the people who make these underpinning technology changes don't have any idea of where it's going to go. They might have some idea, but really it's when you get these technologies into the hands of the masses that all of a sudden everything changes. And we've seen it a few times. And I think that for the last few years, we've all been talking about this project called Kubernetes, this open source project, and a superset of that, which is the Cloud Native Computing Foundation, and all of the projects under its auspices. And these are another one of those. This is just changing what you can do and how you can do it. and it will take a while, and it's too hard to use at first. It's very difficult, and you have a small percentage of developers who really understand it. But in time, as it not necessarily gets more capability, but just gets easier and more accessible, all of a sudden you have this, 1,000 flowers blooming, a billion flowers blooming. And I think that's what is exciting to me right now, is knowing that this is happening again, and not knowing what's going to happen on the other side, but knowing we're going to watch this process again.
But isn't that the way sort of new technologies start anyway? You've got like this small elite group that knows how to do it, and it's easy for them but super hard for everybody else, and then it starts getting more and more democratized, and
Absolutely.
then eventually more and more people pick it up and do it. Although there's this tension because the elite don't really want to democratize it, because there's like, well, the reason I'm getting paid $500,000 is because I know Kubernetes and nobody else does, right? I'm sure it's not that.
It's not. It's probably usually not that crass. Although there is, looking down on people who can't do it, and Kubernetes uses this weird file format called YAML that everyone hates. And if you complain, people are like, well, that's what YAML is what you use. And okay,
what's wrong with YAML? YAML it's like pretty common, I think. But
it's not the most friendly thing in the world, for sure. But it's funny because I spent 7 years at Google working in what we used to call TI, technical infrastructure, and then later was rebranded as Google Cloud. And the internal version of Kubernetes, the thing that kind of started it all, was called Borg. And Google,
that's a better name than Kubernetes.
Borg is a fantastic name. Yes, I probably would have had trouble getting the rights to that. So Borg, Google, especially back then, was known for hiring the best of the best. The top 0.1% of engineers, so hard to get hired. There was a joke internally that Borg config, which was something invented at Google for Google, was the hardest thing, and getting someone who actually understood how it worked. And you're talking the best of the best there, right? So as they externalized it, sure, they made it a lot easier to use with YAML. And now it's down to the top 1% instead of the top 0.1% of developers can actually figure this out, right?
Wow.
So that's where
so I think people can understand sort of the power of cloud, right? Cloud computing. I mean, there's still some companies that are like, I'm still not sure, I want to keep hold of my data, et cetera, et cetera. But there's lots of power in cloud. I mean, there was a bit of a backlash at one point where they said, so for certain applications, it's actually cheaper to go back in-house. Is that still a case with some things?
It's still definitely true. And I want to draw a distinction between cloud computing and cloud native computing. Because for cloud, the power of cloud was you get to use a computer that's not yours, and you can get that up and running immediately.
Oh yeah, it was perfect for startups. It's like, I don't have to buy any equipment. I just slap down my credit card and boom, like 5 minutes later, I've got an app running.
It was incredible. And I was in the aughts, the 2000s, I spent some time at EMC, and I remember we wanted to run a small application that we had written ourselves. We didn't need to buy any software. We just needed a server we could deploy it on. And I can remember, and this was a company that was, calling itself a cloud computing company at the time. If I wanted a server that I could install some software on, a virtual server, by the way, there was a 3-month wait, and they were going to charge me $100,000 a quarter, charge my department $100,000 a quarter,
crap.
because they're going to put a half of an administrator on it. And I mean, versus I can go to a website and I can just put in a credit card and then I have it immediately. Like, that's the power of cloud computing. However, anyone who owns a car or many other thing, a house, knows that in time renting is more expensive than owning, right? And so that elasticity and on big compute jobs, I need 100 servers for a while, right? Or there are 5 days a year where I need 1,000 servers, right? Cloud is amazing for that, because if you have to buy for a heterogeneous set of events, and you've got to scale up and buy enough servers for Black Friday, that is an expensive proposition, and cloud was good at that. But the first wave of cloud computing was essentially saying, okay, these apps that we've learned how to run in our own data centers, let's run those in the cloud. We didn't change how you ran those applications. And that's the key that's coming now, is that when a company like Google or Facebook or the early Twitter, these early, kind of big behemoths, Amazon themselves, they were not writing and running software the way everybody else was. They had moved beyond. And it's really kind of Cloud native computing is adding essentially another layer of abstraction between the developer and the computer. And that's the difference. So cloud native computing, even for companies who are running on-prem, cloud native is a much more modern way to run your applications that in the end should make your developers capable of doing more things than they can do today and addressing more use cases they can than if they're just doing the same thing we were doing in the early 2000s, which is you get a VM and then somebody puts some software on that VM. And if you need 5 of them, then someone gets 5 VMs. And maybe you write a script if you're smart, but you're still dealing with 5 VMs.
Yeah, no, that's, I mean, when I had a startup around 2010 where we were doing some kind of a Twitter bolt-on, and we got that thing up in the server up in 5 minutes using Heroku, right? So everything was ready. You just like build it on your machine, put it up there. 6 weeks later, the app was done. It was beautiful. And so I understand that, but what differentiates this from what we were doing then? Because that's typical cloud computing, right? I just buy a server, get my stuff up there, and be done, right? So how does the native make a difference?
Heroku, I would say, is kind of cloud native computing.
Okay.
I think the early, there are a few of those. Actually, Google's first venture into cloud computing was called App Engine. And very much the same as Heroku. And the idea is I don't want to think about, not only do I not want to think about that hardware, which is what cloud computing got you away from, with like kind of this cloud native computing, I don't even want to think about a VM, a virtual machine at all. I just want to take some code and hand it to you and then let you run it. And you're going to decide what machine it goes on. If it needs to go on more than one machine, if it needs to go on a bunch of machines, if it needs to go on a bunch of regions, you'll actually help me out.
You can just spin up and spin down as many engines as you wanted.
And they all had the right idea. This was saying if you write your software differently, it can run in this cloud native way. Now, what they were doing that was wrong at the time was they were fairly proprietary. You couldn't take your Heroku code and easily run it anywhere, even at App Engine. You couldn't take your App Engine app and easily run it anywhere else. There was still there was magic happening behind the scenes. And at Google, when you wrote code, it would only, we ran it in Borg, and Borg would take care of that. But this wasn't something that was truly going to change everything for everybody because it wasn't developed. I guess I could say it wasn't open source. Right. For something to really change the industry rather than just the customers of a particular company, it had to be developed in such a way that this is really going to work everywhere.
Right.
And that's really why Google moved from where they had been saying, hey, App Engine's the way of the future. We should just do that. And when I got to Google Cloud, Amazon was starting to take off with EC2, their virtual machines, and Apple's over saying, that's dumb. That's not the way to write software. We've got App Engine.
I agree.
But
EC2 is the most complicated mess I've ever seen. I just don't it takes so much time to figure that out. It's like there's got to be a better way.
The thing that made it, what it's become, and I think, for years people will be writing books about how a bookstore from the Pacific Northwest invented cloud computing. But the thing that it was good about it was it felt just like that VM that you were going to get, I was going to get 3 months later from my IT department, right? It was just a VM and I knew what to do with the VM.
Well, the IT people cared about that, but the business didn't care. They just wanted the app. They just wanted it running. They didn't care what it was on.
Yeah. So in terms of cost, we are still seeing that. We are seeing companies who are moving back on-prem, right? Like 37 Signals has talked about that. Like they're going to save, $3 million.
But they're like an edge case. They do all sorts of weird things.
They do, but in reality, I think that a lot of companies, I pay a lot of attention in this market, and a lot of companies are saying, hey, let's think about our cloud spend. Like we didn't do this. We were there's a trade-off that will always be there for buy or rent, and understanding that is important. But that doesn't fire me up as much. Like I think it's a natural thing. We do it ourselves. My company, we were looking at, what do we do in the cloud? What do we do in which cloud? And what do we do on servers that were in a data center somewhere? But what does fire me up is if we can get away from the fact, if every developer gets to the point that I don't have to think about installing this on a computer. I don't think about, and the operations people. I don't have to monitor each of these VMs and have this brittle stack that's serving things. We get to the point that Heroku felt like back then, which is, I've just written some code. Let me give it to the system and let the system do its thing. And then that magic means you're not wasting your time on the boring stuff, right? You're not and that's the magic you experienced at that startup on Heroku. Like, we wrote some code and now everything's running.
Oh yeah, until new versions come in and you're running the wrong gems and something breaks and it's like
right. So
it's not as seamless as it should have been. But I guess are we there yet, or is it still coming?
No, we're not there yet. We're certainly not there. It's funny because there's the reason that kind of Kubernetes took off, I think, was that it was really bringing this modern architecture and really saying, hey, if you really want scalability, you want the ability to deliver this, like we're going to build that here. But what they did more than anything was they got everybody. They were able to use the power of the Google name, which Google had a very, very, powerful name in the early in the teens, in the 20 teens, and was able to say, hey, IBM, hey, Microsoft, eventually, hey, Amazon, hey, Oracle, everybody, let's get the predecessor to my company. We used to be called Mesosphere. We need to all rally behind one way to do this, and we can change the industry. And they did. And so that was a really good idea, saying we're going to do this completely open source. We, Google, aren't going to own it. It's not going to be someone's project. This is going to be the industry's project. And that was really smart. It is still, I would say, immature. And if I go to these conferences, the Cloud Native Computing Conference, or KubeCon, as it's called, there you see these numbers, like 96% of companies are using Kubernetes, which is probably true. However, if you dive in and you talk to anyone at virtually any of these companies, unless they were started in the last 5 years, probably 96% of their stuff isn't running on Kubernetes. Right. Like,
so 97%, which capacity, right? If only 1% of the company is using it, then
exactly. And I think that, and that's literally
using it.
The number we think about, the number I think about a lot is how many of your cores, right? How many of the computers that you're using, of those compute cores that you're using, how many of those are running Kubernetes? That is still small. And the reason it's still small is not because the plumbing hasn't been built out in this technology. Like, they started with the plumbing and the wiring, right? And maybe they're approaching framing. But in order to get 99% of developers to move into this house, you need walls and you need carpets and you need not just framing up there, but and I think that's where we are right now, is that it is still, everyone sees this is the way it's going, but you need technologies and these other waves that you kind of mentioned earlier. There's always been a thing that happened, right? There's a thing that happened, like it or not, the development of things like IIS as a web server, and then in open source there was Apache, and a couple other big ones. But it was when the web server became accessible that all of a sudden your average enterprise developer could really start using this thing. And that last part of making this from this complicated technology to something that your average developer can pretty easily take advantage of, that hasn't happened yet. And that's what I think there's a bunch of us in the industry, some at these big companies, some at smaller companies, are trying to figure out is what do we need to do, and what components of the stack need to change in order to make it so all the software runs this way. Right. And when we do that, then again, we don't know what's going to happen. All we know is the innovation is going to be incredible.
So can you step back a little bit and maybe describe Kubernetes, the technology and the frameworks, and for somebody who doesn't know anything about it at all, where does it fit?
So that's a great question. Kubernetes is what its technical term is. It's a container orchestration platform. And a container orchestration, container, right? Is sure. I don't think they want us to call it a cop. That's a cop out. So a container is a really light way to take code and put it in this virtual thing that allows it to run easily. And software installation used to be a nightmare. And you had it, if you're on Windows, you probably remember these things, DLLs.
Oh
and
yeah.
you might install, and we've got a DLL conflict, or you can't install because you don't have that DLL, and oh, you can't use this version of Acrobat with this version of something else because they use different versions of that DLL, right?
Yeah.
A container was a neat way of saying we can pack it all up in this thing that's much lighter weight than a VM, but is still complete. And
It's got everything you need to be able to run this piece of code.
to run this thing, whatever this thing is.
Yeah. Yeah.
And what had happened in the industry, and like Google and again Airbnb and Twitter, they were all using containers. But in order to really free the developers from thinking about that VM, you want software that takes that container and puts it where it needs to be. So you might say, hey, go run this for me. Or you might say, go run this for me and monitor it. And if it starts to slow down, run more of it. And no developer is ever going to like check a machine and see how that's working. The developer never talks to the machine. They just give it to the system. And I don't know if you remember when Google started, there was people made lots of talk about how they used regular off-the-shelf hardware. They were, at the time, people were buying $1 million boxes, right? Google's like, nope, we assemble these things by ourselves. We have, racks and racks and racks of them. And very importantly, the system was designed so that if one of them broke, it didn't matter. And that was like, wait, what? In fact, at their scale, they had to, right? At their scale, they had, and so they built logic into effectively what became Borg of, hey, you never worry about any of this stuff. If one of these goes down and you're supposed to be running, 10 copies of this because you need that for scale, if that machine dies, the system will go, install it on another one. And that was a kind of a magical moment that the developers and the operators no longer had to think about what's running on what machine. And that was, we call that container orchestration. So you say, here's my container, go. And then the system knows how to do that. So that layer of abstraction that prevented people tried to kind of simulate this with VMs, like I can write a script that will keep checking my VM. And if my VM is not working anymore, then do something. But this was like, no, the system is just smart. And that's what we mean when we say container orchestration.
Well, you don't want the developers messing around in there anyway. That's really more of a systemic thing, right?
And there's for security reasons, you never want a developer to, we call it SSH into a machine, right? No. No one should ever have to do that. And giving that layer of abstraction really did free the developers from doing that. Now, there's a lot of new stuff that has to be solved then, because everyone knows what an IP address is, right? An IP address is how I point to. You think of it as your computer, right? But now we're saying, wait, but my software, I don't want to think of the computer. So really, I want to think of my software as having an IP address, right? And what I just said, it might be running 10 of them because there's a lot of traffic. So now you've got to have a system in place that knows, okay, something's going to be placing a call, but really I know there could be 10 of those, right? Which is, you think of that as a load balancer, but even a load balancer, originally they weren't written for, and these things will be coming and going, right? Like these things, like if that computer goes down or if I need to scale up, I'll build more. Now the load balancer has to be smart enough to understand that and to handle that use case of ephemeral, we call those ephemeral workloads because they might go away, right? So you have to change your networking stack. And so Kubernetes has done all that. And then this service, which is ephemeral, needs to call this other service that's also running in the cluster, right? Okay, well, something's got to handle that. Like, how do I even know where that thing could be? And then how does this thing handle how many of those things are running and which is the right one to send it to? So all of that was built into Kubernetes. It's now we can do this. And really you give us a container and we'll handle the rest. And
you can put whatever you want in the container.
You can put whatever you want.
Self-sufficient.
Yeah. You can put whatever you want in the container. Now, you talked about web, you talked about client server. We do think increasingly of, we're using a computing device. Most of them are shaped like this, right? So it's always talking to something, right? And so we, in a sense, it's client server, right? Where it's still client server. It's just that's changed, and your client might be in a web browser. It might be on these.
Well, they're all nodes now. There's really no such concept as client server because there could be you could be running a server on your phone, and the client is over there. So every piece of equipment it's almost like a node in the network, and everything is connected to everything else, and it works the same way, right?
Absolutely, yeah. So it's, again, as this becomes easier and easier, and as we make it so again, the 99% of developers can take advantage. It's just going to be another explosion of use cases. And this technology, Kubernetes, for the last 5 years, I think most new projects are starting up in it, but we are starting to see interesting things happen. Some of it is happening like technologies say, well, what if I have an old application, I can't rewrite it, but could I use Kubernetes to do the VM scheduling part of it? And we see innovation like that happening. And, when that happens, that will actually, a whole new class of stuff will be possible here. And then we see Kubernetes scaling down because it was really built for data centers and like, here's how you manage your whole data center. But now we see it scaling down in projects to say, well, what if something that wasn't really Kubernetes, but felt like Kubernetes could run on something really small, like as small as a single core, right? Places you have really small things. This idea of it's really easy to take a piece of code and then just go put it in a place and run it. And the other thing that's built into Kubernetes is now here's a new version of that thing, right? Now replace it. Well, that's what we do all the time on all of our devices, in my driveway, here on my desk, on my wrist, all of these, everything that takes off, every vehicle that's leaving a port, that's taking off from an airport, that's taking off from a launch pad, like all of these things are running software. And you just talked, it's all essentially one big network. And so as this becomes adaptable to more and more of those use cases, and it's just a standard way, there's less and less friction to get software from one place to another. It's exciting.
So does Kubernetes decide where the code's going to run? Like let's say I'm running something on my phone and I'm running an app. If the piece of code that it needs to run is on the phone, it will know that it's on the phone, or it'll run it in the cloud, or run it on some server, or how does it know where to go?
Right now, it's not doing that. Right now, it's not doing that. You would today. The app that you're like, when you build the back end for your phone today, to do this, you build an iOS app, right? Doesn't know anything about Kubernetes. There might have been some proofs of concept, but no one's really running Kubernetes on a phone yet. It's placing a call and it doesn't know. It literally does have an IP address, or it has a domain name that it's calling, right? And that's getting routed in today, and that's getting routed to a data center in the world somewhere. And chances are for that app, it's then hitting something that Kubernetes is on the back end. So that developer who wrote that backend, they know they're writing for Kubernetes. Like they wrote their code. And what they know is they put it in a container. And Kubernetes is, as that call comes in and goes from here and hits that data center, Kubernetes is the thing that's saying, oh, I know what app you're calling by the name you called it, and I know where that happens to be running right now. I'll do some authentication things, right? And then I'll redirect that. So today it isn't, and in fact, the person who wrote this probably isn't the person who wrote that backend, right? In fact, most of these apps
usually
are calling APIs from many different companies, and right now, so Kubernetes is really at the receiving end of this today for the most part, and it's taking care of everything that's running, and it might not be that app, right? It might not be just that app. That company might have 100 different things that are running in that data center.
And that's usually the case. And that's why it's such a rat's nest or a hornet's nest or whatever you want to call it, of these things have a million APIs to a bunch of different places. When it breaks, you have no idea how it broke, right?
So that is a big problem with Kubernetes. Absolutely.
Oh, really?
Is that
okay?
Yeah. Oh, yeah. Well, there's some great benefits. Is that you build your application. Usually, when you build it for Kubernetes, you build it in little chunks. We call them services or microservices, another pretty trendy term, right? And all that means is you've broken your application.
No. I think microservices is on the downswing now. We have to come up with a new term.
It's going to be nano services, obviously.
Yeah, exactly. Pico services.
Yes, that's next year. So
that's right.
So when something isn't working well now, it is a more difficult prospect possibly to debug than it was 5 years ago. And maybe I'm saying it's more difficult is the wrong way to look at it. It requires a different set of tooling that is much more immature at this point, right? We've had 2 decades of companies that really help you analyze application performance, and 2 decades of innovating on these tool sets that lets you debug an application and get all kinds of things. Now we've broken into microservices, which is great. Each team can deploy independently. It's better for scalability. It's better for innovation. When you can deploy independently, you can ship whenever you want to. So it's much better for innovation.
Oh yeah.
But when that application is running slow, where do you start? How do you see what's happening? That set of tools, it's coming along in this group, this area we call observability, but it is decades behind what had happened last time. And that is part of this is what has to happen now to make this accessible. All those old tools that we use for debugging are irrelevant. We need a whole new generation, and people are fast at work at that.
Yeah, because everything sort of leverages on something else. It's almost like no tool ever stands alone. Everyone uses some kind of API. I mean, look at, for example, login, right? I mean, every site you go to, there's a Google login or a Facebook login or a Twitter login or something. Hardly anybody has their own login capability, or they add it as an adjunct. So it's like everything's connected. We're assuming everything has to be connected,
and that's just the stuff you see, right? On the back end, it's even more connected than that. It's kind of amazing, and again, it just enables things that are unheard of. You know, my car has a map. And that map is a Google map, right? That's calling Google APIs. Every time I get in, I start driving. Like Google isn't do the routing; they use Garmin for the routing. So it's this crazy set of
I know there's like 1,000 things happening back there, and sometimes I feel that this thing is just held together. It's just like a thin layer of looks good on the outside, but underneath it's just a mess holding it all together, because one thing goes down and everything just craps out.
The Rube Goldberg machine behind many of the applications that we use every day is kind of crazy.
Absolutely. But I think that's how we innovate. It's like we assume we get to a point where a bunch of services are available, then we build an app on top of those services, then we build another app on top of that app, and then we build another app on top of that app, and we just have this sort of layer cake of APIs. And then if something breaks in here, we don't really have the capability to sort of monitor that and make sure if something breaks. For example, if, like, you say you have a travel app and you're hitting all these different sites, maybe you need to hit a different site. If site A is down, maybe you need to hit site B or a different API. And I don't think we're there yet. I think we're just in the, at least it works. As long as it works, it's great. But if it breaks, we don't know what to do. We don't have backups or anything like that.
And it's even, within the API, right? Like, they're using a messaging queue from a vendor, and that messaging queue, right, again, that starts to slow down. It doesn't even have to break. It just slows down. What kind of effects? It is absolutely evolving. Your analogy is fantastic, because when something truly becomes reliable, then you do get to stop thinking about it. There's a period of time where it's mostly reliable, and then the people who are experts at those lower levels can really earn a lot of money. Right. Like, but there comes a time where you just don't even think about it anymore. Right. You just don't even think about it. And so that's where we are right now. We're trying, I'm watching this industry evolve, and I'm watching us progress toward that. As just, there gets to be more reliability. There gets to be more understanding. The tool sets get to be easier and more accessible. I think that's really, really important in Kubernetes land. When you see the surveys of like CIOs and CTOs, like, what's hampering you, what's slowing you down? Inevitably, the number one thing is hiring. We can't hire people fast enough with enough and afford them with enough Kubernetes experience.
Right.
And to me, that's not a problem in the supply. That's a problem in the tooling, right? What that tells me is you still need to be an expert. And
it's still too hard. I guess is it, I mean, what kind of experience do you need to be really good at it?
You need to work with it. like there is no
play with it.
Yeah, there is no substitute. Yeah, there is no substitute right now. It's kind of it's on its own. You get experience using it, and what needs to happen to the tool set, companies like mine and 50 or 100 others, is they need to get better and better, so that's no longer the case. Right. And there are a lot of us who are working on it. I don't doubt that it's happening, and it's probably happening very quickly. It's taking on a difficult problem, but we are progressing, and it is getting better. And I think that we're already starting to see, what used to be, there were 3 companies on earth that could build something really scalable. when I was at Google, I remember one time they brought the Snapchat team in to kind of give a little talk internally, because they did build on top of App Engine, which was proprietary at the time. Probably the smartest thing they ever did,
Right.
because
We got to start somewhere.
Incredibly popular. I remember they were hitting more than 1 million requests a second, which at the time was a mind-blowing number. There were 25 technical people there and no one in operations.
It's amazing for an app that was started by people taking pictures of their homework so that other kids in the class could do it.
Right. No, it's kind of incredible. And they were able to build that without lots of expertise and everything, because it was, this, again, it was proprietary, which was the wrong way to do it. But when you no longer have to think about that stuff, when the system is just good enough, it lets some college kids build something that's going to scale like that. And the rest is history. So,
well, it democratizes all this innovation that someone else, they might be able to do. So this is great.
Yeah, and that's just the right word. And once that innovation has become democratized, then everybody can do it. And when everybody can do it, there's more creativity than you know what to do with. One of the most exciting things that ever happens to me as a product manager, and I've always been in technical, every product I've ever had has been kind of developer focused, is when you see someone use your product and you think, oh, I never thought anyone would do that. It never occurred to me that anyone would use my tool that way. I didn't know you could do that with my product, right? And that's always fantastic. And I know that that's what's going on already, is these companies are building applications that were 10 years ago would have been a pipe dream, or maybe a couple companies in the world could have done it. And now there are thousands of companies that can do it. And in 5 years, there'll be hundreds of thousands of companies that can do it.
For sure. So you're deeply plugged in. I want to switch gears a little bit. You're deeply plugged into the coding, the industry, right? Or the coders and the coding industry and the culture and all that. Where's it going? I mean, there's a lot of people. First of all, I know a lot of coders who are freaking out about layoffs in tech companies, and then they're also freaking out about ChatGPT and it, coding for them. I mean, how is all that affecting the industry?
Right now it's scaring people more than anything. I think ChatGPT
obviously the
really
news is just overblowing things, but
I assume, like, for the last couple of months, like, this is like, no matter what anyone talks to you about, you can say, and what about ChatGPT?
Exactly, right.
But
but I mean, coding outside of ChatGPT, there's still, there's no code movements. There's things going on that are kind of disrupting the coding space. So I'm just curious what your take is.
I think that it's always going to exist. I think that what has happened over time is the time that you spend on essentially writing infrastructure gets lower and lower and lower. I said my first job, I worked at this company that we dealt with electric power data, right? I wrote software that used a modem. You remember what a modem is?
I remember modems.
Modem, and it literally called over the telephone lines power meters, which also had a modem in them, to download data. And every manufacturer, pardon me, had a different protocol they used. HTTP wasn't a thing. And it was literally like, as the developer writing the software, I was in charge of every single byte that went across, every bit that went across, and what came back. And I had to read their manuals, right? When HTTP happened and kind of web APIs happened, the ability to call something, all of a sudden that was standardized, right? As a developer, I spent the first 2 years of what I did writing these protocols and calling these things, right? 5 years later, HTTP existed. It would have been 10 minutes to write code to place that call.
Yeah.
Did I get was I put out of a job? Of course not. What happens is I can do more now. I move up the stack, right? And we saw that happen. And again, the same thing with web. In the beginning, it was really hard to actually write software that was going to run on the web. And as we built more and more capabilities, what's happened is we've gotten more software engineers than ever, not fewer. And when people think, oh my gosh, it's coming for my job's going to go away. It's not. It's going to make more of your job, and you will get to move up the stack, and you'll get to solve more interesting problems. And it actually creates, and I mean, this happens every time that people say, oh, they're coming for my job. And what ends up happening is, no, there's 10 more of you, right? You have 9 of you, have more opportunity than you've ever had. And I think that's what I see all this stuff doing, is just when it makes it easy to use, it's as I said, it started in the beginning, it's a whole new class of use cases will become accessible, and we'll need people to write that software. And it will be different than when I was sitting on my keyboard on a text terminal writing this stuff. However, it's still going to be a job, and it's going to be more interesting than people
Yeah, it's
imagine.
like going back to 2005 and saying you're going to be a React developer, and they're like, what? Or going back
Right,
to
exactly.
99 and saying, or going back to 92 and saying you're going to be a web developer. And they're like, what? Something to do with spiders? I mean, come on.
Right.
There's
Yeah.
no conception that this was happening.
You know what's interesting is I was reading about Grace Hopper. Do you know who Grace Hopper is? Oh, seminal computer scientist. Grace Hopper, she worked for the US Navy. She invented higher order languages. She was the first human on Earth that we know of to say, you know what? People programming in machine language isn't such a good idea. We could create something that allowed the person to write in something that feels natural to them and compile that into machine language. This is
Wow.
the 1950s probably. And she went on to, she invented the compiler, and then she worked on early versions of COBOL. But it was this really
Wow.
she was the first person to say this will make developers much more, people didn't believe it at first, of course. But what's interesting is that I was just reading some quotes from her. I was doing some research for International Women's History Month. And her original goal was people should be able to write software in English and then have the computer do the right thing.
Wow.
And look at what's happening with Chat-GPT right now.
Yeah.
It has taken decades. We're not at 100 years yet, but we are many decades into let's get languages that compile, and then higher order languages, and let's get easier frameworks on top of those languages, and then we have to understand English. Now you have to get ML and AI involved. But we are literally now to the point that people in my own company are saying, right, I've done this before. I said, ChatGPT, write me something to do this. Like, we are really getting to the point, and it's not going to make that job go away. It's just going to make it so you have to have less and less kind of arcane technical knowledge that isn't necessary for the problem that you're trying to solve, right? You're trying to make a really great shopping list app, right? It has nothing to do with iOS. It has nothing to do with Kubernetes. It has nothing to do with the Linux kernel. It has nothing to do with HTTP calls. I just want to make a great app, right? Or a weather app or whatever. And so we are going to get to the point that becomes democratized, as you said, and that means we have a billion flowers blooming.
Yeah, and it's just more and more people doing stuff, and when more and more people who they didn't have the skills before, but now they have the skills to do it, then they can actually make their innovations real, whereas they couldn't do before. It's kind of like what happened with YouTube. It's like all these people were still singing and dancing and creating content, but they were just doing it locally in front of their friends. Now they can do it all around the world. So it allows that expression. Of course, a lot of crap comes with the good, but the good gets unearthed as well, you hope.
Right. And people are still making a living, right? They haven't put entertainment out of business. They've widened the concept of what it means to be an entertainer and the different avenues you have to go. It is very
exactly. So it's time to think like a futurist. It's the year 2033. So it's 10 years out. Where are we going to be in 10 years? Is the no-code movement going to eliminate developers? Where are we going to be in 10 years?
I think that we will see, again, I think we will see this definition of what it means to be a software developer get bigger and bigger and bigger. And there will still be people who are working in the Linux kernel will never be done, or whatever the next great operating system is, right? That will never go away.
Are we going to see more OSs? Because it seems like we've just sort of stagnated on like a couple of OSs, and everything's just built on these code bases. Are we going to see new OSs?
I will tell you, it is there is still experimentation that's going on. One of the interesting things, and this is not my department, but quantum computing will happen at some point. And that will, fundamentally, yes, we will see OS changes happen. However, it is much more likely that as a developer, you no longer care about that. So in 10 years, I think the time that, what it means to be a developer will change, and it will change, and it will change, and it will get up the stack and up the stack and up the stack. Will a developer speak into a microphone and then, an app comes out the other end? I don't know if we'll be quite that far, but we will absolutely, we will spend less and less time on tasks that are, much less relevant to the actual app we're trying to build. Right now, it's still a lot of solving technical problems. That's going to go away. And as that goes away, we will see an explosion. And, as not only operating systems change, and that's just going to make things so much more capable. Chat GPT seems like wizardry to us right now. I'll tell you, to my 10-year-olds, this is going to be like, oh yeah, that rudimentary technology. Think about that. It really will, right?
That's right. That was old school.
Right. Yeah. No, they will. So
that was like DOS.
It's like a flip phone, right? It'll be like them looking at a flip phone, like, oh yeah, that's right.
Yeah.
So we will live in a world that innovation is much more democratized, and even as the internet has and small devices have made computing become more and more common. Think of it as, orders of magnitude more, right? I won't just have, I don't know how many computing devices I have in my house right now, 50 at least, maybe more.
Yeah.
Like it will be in the thousands, right? And we will have we will have more people working in software development. We will have, I hope, kind of a standard way to get an application in a container and put that no matter where it's going. That is something I would like to see happen. Is that and the whole point is that no one has to think about it at that point.
Right. So do we still say learn to code to people if they want to get a good job, learn to code? Do we still say that?
I think that right now it still helps. I would say the one thing I would say is understand data. Understand data too,
data is huge.
Data is underneath everything now, and I think that's the one thing that has changed. Is learning to code is still a good idea. It's easier than ever, right? You don't have to learn how to send bits across the wire like I did, right?
Yeah.
Learn and don't worry about fundamentals all the way down. Learn the new hot stuff, right? Really do, because those layers are just going to get solidified, and there will be a day you just don't have to think about them anyway.
Yeah. Well, I'm actually curious. What is the new, like, what's the latest thing in code? Like, if I were a kid and I wanted to get into coding, what would I be do? What should I do first?
So I would say figure out the first thing to figure out is, do you like the front or do you like the back end? Right? Are you more interested in the front end? One of the JavaScript framework of the day is
React or something like
React
that.
React is a perfect example, right?
Yeah.
Do that. On the back end, if you're like, no, I'm like into the, I want to understand what's going on the other end of that call. Go is a language that has really, really gotten very popular in the last 5 years. It was invented at Google by Rob Pike, whose book I have. He's a coworker of mine at Google, but I studied him in the 80s in computer science.
Nice.
Go is meant to be a new kind of back end language. And the other one I hear on the back end a lot is Rust now. So,
really?
Yeah. Yeah.
What about Python? Or I guess Ruby's gone now. Right? Like nobody uses it anymore.
Ruby's gone.
Yeah.
Ruby's gone. I mean, half the internet is still running it, but no, you don't see innovation happening there. Where you see Python is, I said data. No data.
Yeah.
If on the other hand,
you can't do data without Python. At least that's what I'm hearing.
That's where you still see Python.
Yeah.
And I knew one of Earth's biggest Python experts back at Google used to say, Python is an excellent tool. It's a terrible language. I have to trust his judgment.
So you're saying some front end, so React or some other front end JavaScript framework.
Go.
And
Golang.
Then on the back, Golang on the front?
Yeah. No, on the back.
Golang on the back.
Yeah.
So with those two, you're pretty much unstoppable. Right?
Yeah, I think you really, for the modern stuff that's being written, you've got good. Now, by the way, sorry about your comment section. There's no right answer to that question. I will say that for sure.
No, it just changes so often all the time. I mean, when I did that startup, it was Ruby on Rails. Like that was the thing. Like 2009, everybody was using it. It's like you can get an app up in 3 seconds, and it was great. And now it's everything changes so fast. It's like when you're in that industry, it's almost like you've got to continuously learn, because if you're not continuously learning, you're going to be left behind. Everything changes all the time. And it changes quick.
Amazing. It is amazing. And how we see that over and over again. Yeah. And the other possibilities, you go into management and
you forget about all of it.
You're solving a higher order problems at that.
That's point, right. That's right. Higher order problems. I love it. Yeah. Well, thanks so much. This was a lot of fun. So if somebody wants to get in touch with you, what's the best way?
Probably LinkedIn. I have an unusual last name. I'm still on Twitter, but barely anymore. And my on Mastodon, I'm Dan Ciruli.
Oh, nice.
at hackaderm.io, which is a
Fantastic.
fantastic. If you're not on a Mastodon server yet and you found anything about what I said today interesting, Hackaderm is the site for you.
We'll check it out, and I'll put your info in the show notes so everyone can get directly to you. Well, thank you so much.
Thanks for having me. This has been a blast.
Talk to you soon.
Bye-bye.
Bye.